We're about one piece of paper for you.
Alrighty, so what we're going to do is take a look at some optimization problems. And you've done optimization problems last year. It's just that when you did it last year, every problem turned out to be a quadratic. That's not going to be the case for us because this is calculus. They're also known as max-min problems. So you've seen this a million times, but the rancher sets up the fence next to the barn and wants to give the... Don't shake your head at me, mister. Shut up, you even... Guys. God. Anyways. Max-min problem / optimization. Here's the bad part. All of these problems are going to be graded for accuracy. So this is what it's going to look like. We're going to finish the lesson today. You'll have the first day of optimization problems to work on. When we come back tomorrow, aside from going over the graphing stuff I talked about, we'll also talk about the optimization problems. I will do no problems from start to finish. I will just answer very specific questions, okay, to guide you to where you need to be. Then you'll have another day or two to clean that up before you turn it in to be graded. So even though tonight's homework isn't due tomorrow, you still need to start working on it so that you can ask questions about it the following day. We clear on that? There's like 3 or 4 days of this.
3 or 4 days that will be graded for accuracy, or just 1 day?
3 or 4 days that'll be graded for accuracy.
Do we get more points since it's graded for accuracy?
You bet you do. Yeah, so you rock them, you got no problem to worry about it. You tank it, it won't be a problem. No. Silly girl, you. But the odds are in the back of the book. You can't do anything about that. It would be kind of sick if I just told you that now.
I mean, I can see it happening.
Okay, so let's do this. First problem is a manufacturing problem. So you work for a company, you are an engineer, and you need to design the following problem. You're going to make a box. Okay? Out of cardboard. A rectangular box with a top. Sometimes they'll have tops, sometimes they won't. Is cut from a 10-inch by 15-inch piece of cardboard. Piece of cardboard. A square is cut. A square piece is cut from the sides. Is cut from the sides. What size square will maximize the area? Maximize, spelled that wrong. Maximize the, sorry I lied, the volume. Unfortunately, these problems aren't as algorithmic as the related rates problems. But you will see as you do more of them, you'll start to fall into a pattern. Okay, so I've got a 15 by 10 rectangle. 15 inches here, 10 inches here. I'm going to cut some squares out of the side here and here. We'll talk about the rest of this area over here in a second. But then I'm going to fold that up into a box. And I started with this one. It's a little trickier because we have to include a lid. If it didn't have a lid, it would be easier. We cut the squares out of the 4 corners, fold it up, no lid, done. This one's a little trickier. We don't know how big the square is. So We need to introduce a variable. What do you want to use? X, sounds good. So we'll call the square x by x. This one is also x by x. So if you think about it, after I've cut those squares out of the box, I'm going to then fold it along that edge, and that'll give me the front edge of the box. Can you visualize that? Then I'm going to cut some stuff off the side, and this would be the sides of the box. This would be this would be the, right here would be the sides of the box. But I have to account for the top. Okay, well, how do I do that? Well, I got to cut some stuff off the sides there also. So I'm going to cut something that looks like this, and I don't know how accurate this diagram is, but we'll wing it. And you can see that this should go there. That red rectangle slash square is the bottom of the completed box. Can you see that? Here's the one side, here's the other side, here's the front side. Why is this guy so long? Right, it's got to flip over and be the top. So there'd be a little crease right there. Which would mean, how long is that? X, good. Which would mean that this is also x. So far, so good? Good. Changing colors here. How long? Okay, hold on a second. Let me get rid of this 10's in the way. Get rid of that 10. How long is that?
10 minus 2x.
Beautiful. Everybody good with that? What you already said? 10 minus 2x. Why, Oliver?
Because you're cutting x off both sides. That is
Good. Start with 10, slice x off of both sides. We're good to go. Okay, now the hard part. How long is that? And think carefully before you answer.
10 minus 2x.
Say again?
10 minus 2x.
Nope. Go ahead.
15 minus 4x.
Nope, but you're on the right track. You're getting warmer. How long is this? Or easier question, how do those two distances that we haven't named yet relate to each other?
Would you have to say like, well, you have to use the 10 minus 2x.
No, not for that distance.
So if, like, is it the same as the other bracketed segment?
Yeah, these two are the same length. Why?
Because the top is going to be the same.
Yeah, the top's got to match the bottom of the box. It's a traditional rectangular box. So this top, right here, has to match the bottom. Okay. Which doesn't tell me how long that is yet. We'll get there in a second, but we do need to realize that those two things are equal. Okay, so go.
So 15 halves minus x.
Say again?
15 halves minus x.
Why?
If those are equal, then it would be like, we should put in y from, it would be.
Well, hold on, let me write this down for visual learners. Okay, you want to call this y?
Yeah.
Okay.
So it would be like 2x plus 2y equals 15.
2x plus 2y equals 15.
And then you solve for y.
Solve for y. So that would be 2y is equal to 15 minus 2x, and divide everything by 2, y is equal to 15 halves minus x. Good. That's the hard part of the problem. So let's get rid of the y's, because we're done with them. Whenever possible, we want to try to work in only one variable. 15 halves minus x, 15 halves minus x. Okay, can I erase this? Are you good here? Okay, good. What is it we're trying to maximize? Volume. So now we need a volume. What's the volume of a box? This one you should know. I'm not giving you that one. Did you say base or length? Who's talking? Base? Okay, that's fine. Well, obviously that's not going to work. I've got 3 variables, so I got to go back to the problem. How big is the base of the box? Now it's built. Okay, so I've got a box here. How long is this guy? 10 minus 2x. How long is this guy? 15 halves minus x. And how tall is the box? X. Good. Okay, so let's stop for a second. Is everybody good with that? Stop sleeping in my class. Are we clear? Good. Don't look at me like you're shocked.
I'm not.
Okay, good. Good? So now, this is no good, too many variables, so it's not like related rates where you keep taking, no. We want one variable here. So I'm going to get all fancies in my pantsies. I'm going to change volume to v of x. Because I started with a volume that had all kinds of variables. Now I've narrowed it down. I have a volume, or a function, to represent the volume in terms of x only, which would be x times the quantity 10 minus 2x times the quantity 15 halves minus x. Okay, that's the hard part. Now the easy part is the calculus. I want to maximize that function. How do I do it? Mark, keep going. Confirm that it's a maximum, right? That process is going to repeat over and over and over again. Take the derivative, set it equal to 0, find the critical numbers, put them on a number line, test regions, answer the question. But now you need to decide how you want to do this. You could do a product rule a couple times. You could multiply the whole thing out. That's not bad. How do you want to do it? Multiply the whole thing out? Okay. I'm going to, and I'm just going to go to the next slide. There we go. Next slide. So our function, color change. X times 10 minus 2x times 15 halves minus x. You want to multiply this whole puppy out, huh? Okay, so I'll leave that for the last. I got 150, so 75. There's an x there. 75 minus, that'd cancel, 15x minus 10x plus 2x squared. Check my math there to make sure I did that correctly. Are we good? Right, I just foiled that. 10 times 150 divided by 275, and then the inner would be 2x times 15 halves. The 2's canceled, minus 15 halves. Yeah, okay, so then this would be, let's clean this up, 2x cubed minus 25x squared plus 75x. Ooh, multiplying it out might have been a good way to go. What's the matter? Did I screw up somewhere? There is a distinct possibility.
No.
No, we're good? Can I get a confirmation from somebody? Am I okay?
I did something.
I'm good?
Yeah.
Okay, good. So I want to keep things labeled clearly, so that is v of x. I've done no calculus yet, I've just done some algebra. Now I do some calculus. The nice thing about the optimization problems is you do the work on the front end, and most of the time, the derivatives aren't bad. You can see we've got a nice polynomial. So v prime of x is equal to 6x squared minus 50x plus 75. I don't want to play games with factoring that. So get out your calculators. Fire up that quad program. We're going to set it equal to 0. You need to show this because you're demonstrating, yeah, I know what I'm doing. I'm setting this equal to 0. and therefore x is equal to, I don't remember if they're nice numbers or ugly numbers. They're not? Beautiful. So give me rounded to 3 decimal places. They are
6.371 and 1.962.
Okay, let's stop for a second. I'll give you a second to copy that down. I'm going to go back a slide. We good? Back a slide. I have 2 answers. 6 point blah 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 and 1 point blah blah blah. Do they both work? Does only one of them work, or do neither of them work? One of them works? Which one, smarty pants? You got a 50-50 shot. Come on, Connor. You can do it, buddy. Pick one. Go with it. Bigger one. That's wrong. Sorry, that was harsh on your self-esteem. Good try, Connor. I know your heart was in it. Why doesn't 6 work? Okay.
If you plug in the 6 just to the 10 minus 2x equation, it would be a negative number.
Okay, good. One example. Other example, go back to the original manufacturing problem. This distance is 10. If I cut a 6 out of that, I can't cut, you know what I'm saying? The 2 squares I would cut out would be bigger than the length of the side. That saves us some hassles. Because now I don't really care about this. And I only have to test this. But you got to be careful. Sometimes it could get weird depending on how you list your number line. By the way, what's my domain restrictions on x? What's the smallest x could be? Something greater than 0, correct. If it's 0, we have no box. What's the largest x could be? Less than 5, good. So that might be worth putting in here. X has to be less than 5 but greater than 0. So when I create my first derivative number line here, v prime, I'm going to put 0 on one end. I'm going to put 5 on the other, so it's actually a first derivative number segment. And slap a 1.92 in there. 962, sorry. And remember, it's a first derivative number line, so I'm plugging into the first derivative. What would be a good number to plug in? Pregunta.
Should those be open circles on here?
It don't matter.
Okay.
Yeah, just, you're right, they should be.
But it doesn't matter.
Yeah, no. What number works well to the left of 1.962? 1, good. Put 1 into the function. That's going to be 6 minus 50 is negative 44, plus, is positive. And how about 3? That would be 3 is 150 plus 75 is negative 75, and that's 9 is 50. It's negative. Don't blow this off. Meaning, don't assume that you know it's going to be a maximum and just fill this in. Check it, because sometimes you'll get weird answers like it doesn't work. Okay, so what does that tell us? Well, we already knew that it's a maximum. So, a relative max occurs at x equals 1.962 because v prime changes from positive to negative. Okay, so we're good. We got the math. Now you have to be sure to answer the question. What was the question? What size square will give you the maximum volume? The reason I said you have to answer the question is because there's all kinds of questions I could ask here. I could ask you, how big of a square do you cut out of there? What's the area of the square that you cut out of it? How long is the side of the square? What's the volume of the maximum size box? What are the dimensions of the maximized size box? In this case, we just want to know the square. So our answer would be 1.962 inches by 1.962 inches. And we're done. So you do have to use the calculus in the first derivative test to verify that that is in fact a maximum. If you wanted to get all crazy, you could have used a second derivative test here and skipped the number line. Should I go through that, or you just don't care? Okay, so just wave your hands in the air like you just don't care. Beautiful. Any problems here? We good? Next on the agenda, farmer problem. Yeah, you love farmers. Okay, what are we doing? We're building a fence. Ooh, we're gonna do a money problem. This is great. Switching to red. Numero dos. A rectangular field. Is fenced off along a river. Fencing costs $12 per foot when it's perpendicular to the river. When perpendicular to river. However, it's only $8 per foot when parallel to the river. Find the largest area Farmer Ted can enclose for $3,600. Let's start with a picture. What do you want to call a perpendicular? What was that? There's a raptor loose in the building. What do you want to call the perpendicular distances? X works just great for me. You don't have to use X, you can use whatever you want. I'm going to choose X. What would you like to call the parallel side? Y. You guys are so creative. What's the matter?
Like, X normally goes like horizontal.
Is that freaking you out?
Yes.
Does anybody have an opposition to changing it? That's why we have erasers.
Thanks.
Ooh, I lost part of my fence. What would you like to call them? You want to
Like-
switch them, or you want to
yeah, switch
introduce
them.
different
Just
variables?
switch them.
We could use Greek letters if you'd like. We could
No.
use a smiley face
X and Y
and a drawing of a dog. We could do whatever you want.
X and Y is fine.
Emojis? I don't have emojis built in.
You can pick one.
You can draw them.
So you want perpendicular to be the poop emoji, and the horizontal to be the 100 emoji. That ain't gonna happen. Okay, so we'll switch it. We'll keep things simple. All right.
Bothering me.
It's okay, it's actually.
We
Actually,
understand.
can you switch it back? No.
Let's fight about it. Okay, so got a nice, pretty picture. What are we putting in the fencing, by the way? I like to get a backstory here on Farmer Ted. What's he? He's a what kind of rancher?
Lifestyle.
I'm sorry, an honor rancher?
Crocodile.
Odd chicken. So he's building a fence for odd chicken. Is it a champion chicken, or is it just? Just, he can only afford, he can afford 3,600 feet of fencing, but he can't buy more than odd chickens. And the chicken's name is? Philip. All right, we can go with it.
Philip is our savior. Now I gotta draw them.
That looks more like a duck.
Can we change it to dog?
Philip, 2 L's or 1?
Let's go with one.
Go three.
I like the way you guys think.
Looks like it's actually
Yeah, it does kind of look
No,
like
I don't like three L's.
chicken
I
fingers
cannot
if you
stand
did it
three
all
L's.
Force kept it.
I like it.
2 is too many L's.
Yeah, where's
Maybe
the
that's what
frosting?
Philip's gonna be turned into.
What are we naming
His
our-
destiny is to be chicken nuggets. Question,
Where's the roasted banana?
where's,
Oh my god.
I have a question.
Oh
Yeah,
yeah,
just
where's the
sell
reggae
roasted
banana?
that's a great question. Where's my banana?
You put it in the closet.
We'll deal with that in a second. Let's get Philip out of the way. I need an equation now. And once we get the equation set up, then the rest is easy because we know that all we have to do is some simple calculus. So what do we got?
Find the area, so it's x times y.
Okay, so we'll start with the area. The area that Philip can roam is x times y. Okay, not bad. It's a good start. Raj, what do you got?
24x plus 8y is 3600.
24x plus 8y is 3,600. Could you explain that a little bit?
That's the amount of money we spent.
Right, that's a cost factor, or a cost equation.
Wait,
Oh, it is.
Oh, 12y plus 12y.
it should be 20.
Yeah.
Plus
No, what? That's confusing. It's confusing me too.
Okay, so it should be what? 12x,
12y.
12Y.
12y. I'm still freaked out about the banana. 12y plus 16x? 16, yeah. No,
24. No, 24y
plus
plus
24y plus
wait, perpendicular, yeah, right, 24y.
Oh my god.
You're
I'm off-
2y.
I'm off my A game.
How dare you.
24y plus
8x.
8x, thank you. Almost wrote a y again.
Exactly.
No, we have.
First of this x amount of the x.
Okay, so now what? There's a problem there because I'm.
What the hell?
I think I would have noticed this. I just stole a 6-foot banana out of it. It's not like they're gonna jam it in their backpack.
Was it in that closet?
No, couldn't be in that closet.
Bam, pops out. Anything's possible. We should stop everything we're doing and find it.
Okay, I've got 2 equations. One is a cost, one is an area. So now we have to figure out how to combine the two. The problem is well, there is no problem. We have to ask ourselves, what are we maximizing? Area. So I want an equation in terms of area. So I'm going to work with this, but I've got 2 variables. How do I use that? Solve for one of the variables. It's completely up to you which variable you want to solve for. Solve for x. How many want x? Raise your hand. How many want y? X it is.
24 by 8, that means we don't have any decimals because there's 2 y's.
Gotta think ahead.
That's true, okay, I'm okay with
What's 3600 divided by 8?
Isn't it minus 24?
Yes, it is. Good catch. Seeing who's paying attention. Way to go, Lainey.
It's 450.
What is this?
450.
450. Oh, that worked out nice. Okay. Okay, now I'm going to get all fancies in my pantsies again. The area function in terms of y will become y times 450 minus 3y. which is the same thing as negative 3. What?
Yeah, he's right.
Oh, no.
Where'd you get?
Yeah,
Where'd you get the extra Y on the?
It's, he plugged it in.
Oh, okay, I got it, yeah, my bad.
Next. What? Come on, say it loud, say it proud. I
No,
just
I
didn't-
was thinking of something else. I was thinking that you can factor out a 3, but you don't need to do
I
that.
could, but I don't, yeah. Take the derivative. A prime of y is negative 6y plus 450. Set it equal to 0. And y is equal to
75.
how much? 75. I think we can get it done on this. Come over here, do my A prime number line. Domain restriction. What's the biggest value y can be? Sorry, let's start with the easy one. What's the smallest value y can be? 0, so it makes no sense to put in negative numbers. What's the biggest y could be? Ballpark, it doesn't have to be exact. In other words, let's suppose since we only have Philip, I wanted a very skinny but tall pen for him to just run back and forth. So he's looking at the river, he's not looking at the river. He's looking at the river, he's not looking at the river.
Across the river.
Like 150. Would that be exclusive?
It's reasonable. I mean, there's probably, we could calculate what that number is, but we don't care. We just want to, we don't want to pick numbers that are too far away from 75 because strange things will happen.
Can Philip swim?
Can what swim? I don't, hold on, I'll check. Can Philip swim?
No, he's afraid of water.
He's afraid of water.
Good thing there's no.
Yeah.
That's why we don't have to, that's why you put him next to the river, because we don't have to worry about him getting free.
But then what if he goes in the river? There's no.
Well, he won't if he's afraid of the river.
But what if he like?
he does?
What if
What if he
He won't.
What if it's dark?
What if he sleepwalks?
You're like, nope.
Do you go out and play on 53 during rush hour? No, because you're afraid of it, right?
But you're sleepwalking.
Philip is a chicken. Yes, he is. He's never to not go in the water.
All right.
Water.
Let's try something fairly close like 50. So if I put 50 into that function, do I have a plus or a minus? 50 times 6 is negative 300 plus 450 would be positive. That's good. And then, I don't know, a hundo minus. So we confirm that the 75 is actually the maximum. I'm running out of space to write. I'll sneak it in here in green, which you can't read. Relative max, but you know what I'm writing, occurs at y equals 75 because A prime changes from positive to negative. That's a good call.
Oh, I can read that.
Okay, now, last thing, did we answer the question? What does the question say?
Find the largest area.
We didn't answer the question. So we gotta find the largest area. Which means I need to find x. Well, how do I find x?
Plug Y in.
Yeah, plug y into there. So 3 times 75 is 2 1/4 from 450 is x is equal to deuce and a quarter. And therefore the area would be deuce and a quarter times 75. And Philip will be happy to realize that he has
1,687.
1,687.5. What? What are my units here? Squared feet.
That's not right.
How did you
It's
get
six.
75?
It's 6.
225 times 75.
Yeah, how do you have 0.5?
There's no point.
Oh, I thought it was just 1,500. No, that's
Jimmy.
Shimmy.
That's a lot of room for one chicken.
It's a free range. What is it? 16,875 square feet. That's a big chicken pen for a chicken.
What if Philip is just really, really big?
Maybe it is a big chicken. How big's Philip?
More blue.
Normal size chicken.
Foot tall.
Uh-huh.
How tall are chickens?
I don't know.
How tall are you?
Reading has
You're in
lots of
Belgium.
chickens.
I have to be a little bigger. Okay, Mary.
Were they 225
I took this value of y and plugged it in there. And then found out what x is. Okay, so that's like, remember when we were doing related rates, that's our snapshot. So the snapshot is where the maximum occurs. Y is 75, x is 225. Answer the question. Okay? All right, let's do one more, which would be something that does not relate to something like manufacturing or farm or tech.
What's your question?
I'm sorry?
What's your question on how we could find the Rasta banana?
Yeah. Oh, don't worry, I'm gonna find the Rasta banana.
That's actually, I'm so upset about that right now.
Yeah, I mean, I'm joking, but I'm upset too. Who took a banana out of my classroom?
It hasn't moved.
What else do you take?
Sorry, I think they never, what is it?
Custodians?
No, it's banana fana. That's two different banana something.
Why didn't anyone write it?
It had to be what you're freshman.
Banana.
That banana is bigger than most of my freshmen, so.
Oh, yeah. It also could be the custodians.
Why would they take the banana?
I don't know.
What was they doing?
Are there cameras?
Yeah, in the hallway.
We will check the cameras. Check the cameras. It's fine. Those are reasonable. You just do like what we
Never
can
define like this, but I'm jumping inside. Alright, I see someone security guards.
I'm trying.
No chickens, no cardboard boxes, no river, just a straight up boring question. What can you tell me about the function y equals 4 minus x squared? I'm sorry?
Quadrant.
It is a quadratic. Yes, it is a difference of squares, good. It is a parabola, upside down, good. For those of you who are visual learners, we can draw that aforementioned parabola. We might need to find these 2 points down at the bottom, but we'll see if we can get by without it. And then we've got a point 0, 2, which is right here. Is this a max or a min problem? Min, right, because we're doing closest. Let's pick a random point on the parabola. Let's say over here. What are the coordinates of that random point? Nope.
Oh, not something.
Square root of 2, comma 2.
Nope. Nope. This point, not this point is at 2, yes. That's at 0, 2. This random point on the parabola has the coordinates?
Isn't it x comma f minus x? Or f, comma.
X, comma,
X. Or
f of x, which is?
4 minus.
There we go. Because remember, we're no longer using x, y for the most part. We're doing x comma f of x, and we know what f of x is in this case. It's 4 minus x squared. And what is it I want to minimize? Distance. So I want to minimize this guy, which we'll call d for distance. And you all know the distance formula, right? Distance is equal to the square root of x minus 0 quantity squared plus, because insight, 4 minus x squared minus 2 quantity squared. Easy peasy. Now here's the cool thing. We're going to end up multiplying that thing out to make it easier. The problem is we're going to get a function, a polynomial, under a radical, which means we can rewrite it as the polynomial raised to the 1/2 power and go through that, and you got chain rule, and then things will get a little bit ugly. But you can remember one simple idea. If I'm minimizing or maximizing a radical, all I need to do is minimize or maximize the radicand. You know what the radicand is? It's the stuff underneath, yeah. This is the radicand, the function. We can ignore the square root. That's if the entire function is under a square root. So all I'm going to end up minimizing is this stuff underneath. Okay, so let's call that a new function. We'll call it alpha. So alpha is x squared. Let's see, that's 2 minus x to the 4th. I think I did that right, did I not? Right, because that's 2 minus x squared. So square the first term is 4, multiply 2 together is negative 2x squared, times 2 is negative 4x squared, square the last term, negative, okay. Which is, just for those of us that are weird, minus 3x squared plus 4. Okay. And again, we're going to minimize this. I don't care about raising it to the 1/2 power, because if you minimize a function with a radical, you can just minimize the radicand and we're good to go. Now we need alpha prime. Which is 2x times the quantity 2x squared minus 3. And we want that to be equal to 0. So my critical numbers are x equals 0 from here, and that monster, which would be plus or minus the square root of 3/2. Why does the critical number of 0 not make any sense? Well, hold on. Let me rephrase my question. Why does it make so much sense that it doesn't make sense? I'm sure that cleared everything up, right?
There's already one on the graph.
We lose you there.
It's too close. Lost myself too.
How close is it? It's on it, which would mean
That's the same.
it's the same point. That doesn't answer the question. So there are two answers. One on the left, one on the right. And then I'm going to stop there because the bell's going to ring. But what will we do next? Put all those numbers on a number line, test regions, good to go. Okay? Yeah, so for those of you, again, that are visual learners, we would have 1 point up here. We do? Oh, good. Sorry, I thought it was 5. Square root of 3/2 is about
1.22.
1.22, so we'd have another one here, and we'd have another one here. And now we need to figure out which one of these guys is the shortest distance. Okay. So, alpha prime number line, 0, negative square root of 3/2, square root of 3/2. So knowing that that's 1 point, what'd you say, 2 something?
1.22.
Close enough. I'm going to pick 1 in here, put it back in here. If I put 1 in here, I would get a negative times a positive, so that would be negative. That's decreasing. Put in a big honking number here like 3. That would be positive times positive is positive. Put in a negative 1, so that's a negative times a negative, which is positive. And put in negative 3. I would get a positive times a negative, which is negative. Okay. Uh-oh. What just happened?
2 minimums.
2 minimums. Right. Minima. Does that make sense? Well, yeah, it should, because that parabola is symmetric about the y-axis. So I actually have 2 spots where that occurs. Notice again, when you're done, go back to the problem and see what it's asking you. This is not asking you for the x coordinates, it's asking you for the point. So you have to figure out what the y coordinate of these things is. So you got to take the square root of 3/2 and put it back into the original function. Well, that's not too bad. Square root of 3/2 squared is 3/2. 1.5 from that is 2.5, which 2.5 is the same thing as 5/2. There's our answer. No units, because we're dealing with just weird algebra stuff.
So when we do these types of optimization problems, will most of them be like farmer, whatever, and the river and the...
There's a veritable potpourri of opportunities. There's some volume stuff with geometry. There's I think there's a pool problem. There's simple things like this. And
Okay.
okay, so everybody good? What's going on? Tomorrow you come in with your 2 days of graphing done. We'll go over that. We'll also start answering specific questions about the optimization problems to get you going. I'm thinking that since today is Wednesday, the first optimization problems would be due on Monday, but I'll talk over that.